Hello, everyone. Good afternoon. So what I will do basically now, the next 45 minutes, talk a bit about our project and basically how we basically start with legacy application and with a legacy stack and basically modernize it a bit. And at the same time scale it a bit, but still being like a legacy stack. Who am I? I basically came to Berlin and did computer science. Then was a freelancer at various startups, and before I joined basically Rocket in 2012. As you might have heard, at Rocket, like we basically launched a lot of different e-commerce models around the globe. And I was basically part of it. And since 2015, I'm actually at Rocket Labs, which is basically a subsidiary of Rocket Internet. And I will tell you a bit like what we are doing, what is like the main project, what we built in there, because that's basically what I did there. I call myself a bit like an e-commerce geek, so it's like, yeah, I'm actually from the coding background, but I also love e-commerce, so it's that's a bit the background. So in my title, I basically using like basically two words, and maybe let's define them before we go into the details of the project. So basically, what means legacy? Yeah, I mean, there's like I basically quoted some definition from Wikipedia. At the end of the day, it's like a method, technology, and computer system which is outdated. And why it's not good? Like why has it certain risk? It basically has like a risk of like hard to maintain, to improve, and to extend. And it's of course like a big drawback because actually that's what we want to always to build. Like we want to add like new functionality in there. We want to have like more customers, more products in e-commerce, and of course like we want to extend it. Yeah, if you have like a legacy stack, that's basically hard to do. Of course, it also applies like some security issues. Yeah, if you use like an outdated technologies, of course you are more prone to errors. You are more prone to get attacked. You cannot really fix them. And of course, like doing it globally as a company as we are at Rocket, I mean that's a danger, and we need to avoid that. Of course, also integration with third-party systems getting difficult. I think we heard it in the last couple of days a lot about like retailers and big companies how they try to modernize their stacks, and I think that's a big issue for them because basically they have like systems which they cannot integrate like with new systems, and of course it's also always a problem. So you keep to be up to the standards, yeah. Like it's very hard like to implement a REST API with a system which is like 20 years old. And eventually, I mean, leading all to these facts, I mean, you have eventually high hardware and software cost, yeah. Because if there's like a monolithic application, you cannot really unbox it, you cannot really tune it, it needs to run on one box. You might not even be so much scalable because you have like some technologies which is not really scaling. Of course, the software cost is also hard, yeah, basically coming back to the first fact, it's hard to maintain. So you need like more manpower, more time to fix actually bugs or even like add more functionality in there. What is actually scalability? I mean, scalability also there, I quoted like some definitions of Wikipedia, and eventually I think the most important thing about it is it's like basically capability of a system, network, or process to handle a growing amount of work, or its potential to be enlarged to accommodate that growth. Yeah, what does it actually mean, and what does it give us for opportunities? It basically gives us the opportunity to enhance additional features. Yeah, I mean, what we normally like at Rocket call like we grow our business. Yeah, we need to add like more functionality, more features to an existing software. We eventually also cover like extra user workflows. What does it mean actually? It means basically that more people can use with the software. Like in e-commerce normally, it's not only that like the content team can work with it, but also maybe the marketing team, the CRM department, the warehouse system, and so on. Of course, also, very important for us is like this high geographic density, so that we can basically use the software not only like in specific regions, but basically globally, Africa, South America, Southeast Asia, and so on. And of course, yeah, and that's, I mean, what we understand as a developer most of the time about scalability, and of course that also includes that one, that we cover higher load. Higher user output, so basically we can process more orders, basically can handle more products. Eventually meaning to the fact that we of course also have like lower software and hardware cost. That's basically the things what we understand at Rocket like a scalable, to have like a scalable system. So it's not only like more output, but it also means like more features. So coming back to where we basically are, or like where we started in 2013 with the Seller Center project. So what is basically the software which we build on. I mean, as you know, like from a normal e-commerce model, it's like very important to have like a good consumer front end, like the customer can buy products, but actually that's not all of that. Yeah? If you look in the successful models of Amazon, of Alibaba, they basically have a like high, very good marketplace. And actually that means they enable like big sellers, big retailers to log in the platform, to upload their product, process orders, joining promotions, see financial details and whatever it means. And in 2013, we basically did like a market analysis. We realized, okay, we don't have it in our rocket companies, in our rocket e-commerce ventures, but we need it. Yeah? We realized there's not so much good on the market, so let's build something. Yeah? Since we are like always very pragmatic at Rocket, we basically trying to be things very lean and very fast in putting it out there. So basically, we decided into this setup at the beginning. Yeah, we chosen a Saint Framework 1 application because we had like some groundwork already done, and we didn't want to reinvent the wheel. We used like some MySQL storage because we were used to MySQL, and as an internal session storage and cache storage, we used Memcache because it was used to be. Of course, since we hosted the application on multiple hosts, we also needed like some file sharing, like for images and stuff like that. So we used like NFS. Yeah. Then, of course, we had also like some external systems, like we didn't do all of the stuff what we needed to do, like email sending, whatever was done by some third-party systems. And of course, like the actual connection to the shop system to actually upload the products to see them or to getting the orders, we also had like some third-party connections. On top of that, we also established, like a public-facing API, because it was actually pretty important that we also like building an API and endpoint, so like other sellers can integrate end-to-end. Yeah? We have chosen like an XML approach, not a REST approach for whatever reasons back at that time, and like quite a lot of logic was like handled via crons, yeah, because it's like the fastest setup. Yeah, you just install a cron tab and add one cron, and you basically process some data. If you're looking today at it, I mean, yeah, you can basically say it's pretty legacy. Zen Framework 1 is out since 2006. I even checked it before, so it's like an 11-year-old technology. MySQL is basically outdated in terms of Postgres, NoSQL, and all this stuff. But back in the time, it was totally okay, because our application had like 0 sellers, 0 products, and 0 orders. So it was totally fine for our use case. Of course, what is like the normal workflow of a software lifecycle? I mean, you basically launch the software, and of course, you have like the first bugs. Yeah, you detect the first bugs, you need to fix them. Eventually, you add like more features to it. Then, of course, you add like some more bugs, what you actually need to fix. You're adding more features, and you're starting to a point where you're basically adding more and more bugs. But you'll still be able to control it, and you're still able to add like more features. Of course, like you might hire like 2, 3 more developers to the team. You can still produce something. But then you're basically adding like bugs in new features because you don't know really how to build them, and you're adding bugs in old features. And then it starts to the point where it gets a bit bad, because at the end it's like you're slowly getting out new features, and it doesn't really help to add more people into the tech stack, because they eventually will come to the point in 8 and 9 that they're adding bugs in new functionality and old functionality. So what does it mean? You're basically adding more and more bugs because you're not really aware what you're doing, and you're eventually doing less features. Yeah, what does less features mean? It basically needs frustration everywhere. Yeah, frustration as a developer because I don't want to fix bugs, frustration as a product manager because you cannot design new products, and frustration, of course, of business because they don't get new functionality out. Pretty bad in terms of scaling. So how to get out of this? How did we get out of that? Because it also happened to us. Yeah, we started lean, we added some new stuff, and then error happened. We fixed them, we added new stuff, and more error happens. Simple as that. Still to say that in 2017, but we started to write unit and integration tests. Yeah, we basically covered our platform. We didn't really do it from state of the beginning because we didn't really know like where are we going. Yeah, because we didn't know like what is really the output of the software eventually. The good fact of this one, it's basically it leads to better decoupled code. Yeah, since testable code is better decoupled and you can better test it. Eventually also, soon, as a matter of fact, you look into software complexity, which is a really important thing. And you're basically looking in 2 metrics is there, code coverage and cyclomatic complexity. So you're basically seeing all of a sudden, code which you basically need to test, and you see basically code which is hard to test because it has a high cyclomatic complexity. And you actually also realize during that effect that you have a lot of bugs and things which are very core of your business. In our specific seller center case, it's basically the order processing and the product, because this is the base concept. I mean, of course, there's like additional functionality on it, but this is the base part of it. And since it's the base part of it and there's the most business logic, it also holds the most cyclotic complexity. And of course, it's hard to cover it with test. I mean, we somehow made it done. And we basically then applied the rule that we will always cover like new occurrences of bugs with new test. And also basically following the boy scout rule that we slowly basically improve the code when we see it, when it's needed. Yeah, so the idea is, yeah, when you see code, you basically try to make it a bit more testable and basically leave it better behind as it was before. Eventually, we then came also to the fact that unit integration test might not be everything, because we have like different devices. We started to have an Android app, of course, more users, more browsers. Yeah, I mean, there's like different browser usage. Like in India, you have a lot of Internet Explorer 8 still around, and so on. So we started to use also acceptance testing, so end-to-end user testing for components. We started pretty late, and it's actually also a good a recommendation of mine, because it's like very prone to errors. It's very hard to establish a good acceptance testing, and it's not easy to establish. But it's eventually you will come to a point where you actually need to do it when you basically have more output and more features, because you cannot really test everything manually, because of course, and the manual effort of course prone to errors. So, and when you have like all of this together, it makes literally a lot of sense to, at the end, you're already in continuous integration. Yeah, because if you test your code base completely all the time with unit integration, acceptance test, you can basically merge all the time everything to the master and basically continuously test it. Of course, also test it before it goes to the master. Having that in place, what's the next steps? Of course, continuous delivery. Yeah. When you're like having the setup of like continuous testing everywhere around, you can also ship the product continuously to life, because you don't need to care about so much that something is broken, because you cover it up front there. And coming back to the things, if you're introducing new errors, you cover it next time with a test and it will not happen again. But what did we do basically with the monolith? Yeah, as I showed you before, I mean, we still had this Zen Framework 1 PHP monolith application. How can we like basically tackle it a bit more down? We basically started to define boundaries. And it's actually a good thing to do later in the process, not at the beginning, because later it's much clearer where basically your boundaries in your software are. Yeah? Because at the beginning, we would probably have like set a boundary between orders and products, which eventually now doesn't feel correctly, because it's way too big. A product and an order in an e-commerce site, it's way too big if you add a lot of functionality in there. So you might need to cut it slower. But not only, but you need to basically think about boundaries in two ways. You need to basically define it internally via services, how they interact with each other, but of course also externally via API. So what do you expose to the outside, and what do you keep inside? And when you have this boundary stable, yeah, maybe in a definition way, maybe in an automatic testing way, that like different services can interact with each other and know models and stuff like that, then you are already pretty far. Of course, you come also like with some concept of domain-driven design and things like that around, but this is basically the base idea. And then there's like basically two things which eventually lead to the fact that you need to follow solid of these things, because if you follow the solid principles, then all of the other things come basically more or less out of the box. Yeah? Because if you follow the solid, it's more easier to write tests. It's more easier to define the boundaries, yeah? Because like your single class is just doing one thing. And last but not least, but also the I gets very soon important, because if you basically want to write good tests, you come to a point where you need like to have a good dependency injection system in your tech stack. And what is also like always a high state on our side, that we never basically try to do it. I mean, we as a coder are also lazy, and we want to produce something. So we also always trying to use like third-party tools who do something, yeah? So we will never implement something like logging and something like sending HTTP requests. I mean, there's tons of libraries. And especially in the PHP world with Composer, which changed everything, you can basically use every library very easily. I mean, you just implement it and basically using this one. The same thing is what I said before when we're connecting to third-party systems. There are like tons of SDK out of it, which you can basically use. And they are, of course, way easier to use instead of doing it from yourself. That leads eventually to the fact that you have like more time to focus on the actual business problem. Because, I mean, yeah, for us, we want to add like more functionality and feature set to our seller center platform, like to add more functionalities in there. We don't want to face the problems like how do we log correctly, how do we connect to some third-party systems, how to implement an OAuth server, or how to connect to an OAuth server, or what might be the things, because it's not really the use case. It's not our business problem. Our business problem is basically adding more functionality to a platform which basically acts in emerging markets, like handle specific laws in Brazil, in Russia, in Australia, or whatsoever. I mean, in this state, we are basically in a I call it like in a fully tested monolithic application. Yeah, we still have a monolithic application, and it's working quite fine. We define some boundaries in the world. Of course, we use a lot of PHP tools, which are basically supporting this one. But of course, we're coming like to a place where we realize, I mean, PHP is a great language, and I like it a lot, but it's not the perfect language. And in certain things, it's actually not a good choice. And then there's like one big thing out of the market, which is Golang. It's like a Google language, I think invented like in 2012, 2013, public since then, and it fits very good to PHP because it's basically built around concurrency. And you can basically very easily build concurrent things. You can send like things in masses in parallel with a very easy task, which is very hard to achieve in a PHP world. But not only that, it's like super fast, and also has a very, very low memory footprint. Yeah, so it's like there's no comparison about PHP or even Java because it uses like very, very less resources. And eventually has like an interesting concept of duck typing that it basically combines the strengths of a highly typed language like Java, where you basically clearly need to define that's your type, to like a PHP language which is like loosely typed. Yeah, it basically you doesn't need to do anything. Everything can be everything. Where Golang uses this duck typing, which eventually means like he tries to auto-guess. It looks like a duck, then it is a duck. I actually was thinking also to show some code, but I'm skipping basically the part because of the time. It was simply not fitting in the concept. And it was also like a package management. Of course, since the language is pretty new, there's not so many packages than in other languages, but it's very, very growing very, very quickly because it's like has a high traction because of the things about concurrency. A lot of people using it, and Google is using it also a lot internally for a lot of things. I mean, next off, I mean, when you realize, all of a sudden you have like a PHP stack in mind and build like some Go services around it who can basically execute some fast in parallel. You're good in scaling, but then you eventually end up to the fact that your MySQL is like your database is the bottleneck. Why? Because the database is always a bit the bottleneck. Of course, the first idea is always, let's move away from MySQL and use some other tools. And we tested it also a bit internally, but eventually we realized also with Postgres we would have more or less the same problems. And like any migration to a NoSQL database turned out to be too expensive, too hard to achieve. It was just, especially with our monolithic application. So what actually did we do? I mean, first of all, we checked our indexes. So, and I would recommend it to everyone to do it because I think you will find a lot of issues. I mean, in our case, we basically dropped a lot of indexes which were simply they're duplicated, so that made like inserting in a database empty. We added also a lot of indexes which you simply missed, and you can basically achieve that. You should really use InnoDB and never MyISAM. Because there's simply no use case. I mean, like I think the MyISAM support was basically dropped by MySQL in 2013, and they're just like it's still there just for legacy reason. And InnoDB is like always better. There's not a single use case I have seen in my I think like 10 years of professional experience where there is still a use case for MyISAM. I mean, InnoDB gives you also consistency about your data and gives you like transactions. So you should really use it. And as soon as you want to use something what just MyISAM offers, like full text search, you probably don't want to go with any of them. You probably don't want to go with MySQL. There are better tools around that. I mean, maybe, and that's also what we realized, there are also some more storage engines like memory and archive, what we're also actually using here and there, where you can basically have a look at it. You basically should use like the tools to measure and optimize your MySQL database. There are tons of tools on the market. Percona is probably a bit like the leader in the tool set, but there's also a lot of other free open tools around it. I highly suggest to have a look at PT Query Digits, which basically like parses your slow query log and basically sorts you everything based not on the amount which is like the slowest query, but basically how often also a query is executed. Because eventually you want to optimize the query which runs very often and are a bit slowish. You don't really want to optimize the slowest query, which just like might run once per day because it does like some calculation for your BI team or for your marketing department. You actually want to optimize the queries which really run like every minute, every second based on some logic on the application. Additionally, it makes a lot of sense to compress the data because you end up, especially in the e-commerce world, in our case, that of course like a product has a lot of properties. You have a lot of attributes depending if it's a fashion product, a a monitor, a computer, whatever, you store a lot of data, and eventually you store it in some text files, in some text fields. It's either like in one single text field, compressed as a JSON, or in multiple text fields. Eventually, you end up with a lot of data, and it makes a lot of sense to compress it, because its compression more or less comes free in InnoDB. So it's like you don't have to have any overhead. Of course, there is a bit more effort because you need to uncompress, or MySQL is internally uncompressing and compressing the data. But I show you in a second some metrics which give you I think that's worth it to do. Maybe you can even hex it. Yeah? Once you hex it, basically you cannot really see what's in there. But of course, it gives you even additional benefit that you keep even the data size lower. You should really check your MySQL configuration. Yeah? For example, like query cache and buffer size, because often, especially in our application, it really doesn't make sense to have any query cache. And also Pecona recommends that often because we have like so many wide operations to the database about price changes, stock changes, and the seller is changing something, and this guy, and the order is processing. So it's actually more work for MySQL to update the query cache correctly instead of using them. Same with buffer. In the InnoDB buffer, it makes a lot of sense that the whole database, or at least as much as possible, is in the InnoDB buffer. Of course, nothing to take away from the other services. There's tons of other InnoDB configurations where you can look at it, which I will not cover there, but I just wanted to have it there. And you should also look in the log behaviors of your queries and of your usage, because what is the side effect of InnoDB, and if you like using transactions, that it basically applies like some row logging and some additional logging, which is a bit more complicated. But you often see the effect that like when two similar threads are basically trying to access the same data, they might like log each other. And so you can definitely also optimize that one. Yeah? In our specific example, we had like the use case that we basically started a transaction at the beginning of each request and basically we're committing it at the end. This is not a very smart idea because it might like hold the transaction open for 1 or 2 seconds, and then there might be like a next person coming on the same page, manipulating the same product, and there might be like some issues there. You can so the idea is basically that you check in your logs and how do they happen, and basically rearrange your software around it. And last but not least, there's also like so-called in the Barracuda file format, which is basically an InnoDB file format, which came out since, I think, 2013, 2012, which once again is super transparent for you as a developer. Yeah, it doesn't really make a difference which file format internally you use it, but this Barracuda format can basically compress the data much better. And disadvantage, last but not least, there's also specific MySQL keywords which you can use there, because MySQL is not always very fast in certain areas. Yeah? We basically sometimes have the fact that this MySQL query optimizer is not optimizing the queries as you have to be. Yeah? You basically run with an explain afterwards on the query, and you realize that's not the right way to do. And there's like certain keywords basically where you can force them to do the right thing. With a straight join, you can basically force to use a specific index because you know it's better than that. Because at the end, this MySQL query optimizer is not always super smart. And that's actually our use case what I wanted to share, like at least show you some numbers, because we had like the use case that we basically had like 2 big database tables. Yeah, we had like one big database table with all of our products, and we have one big database about our product history because we are storing like what has been changed in there. And we eventually like applied the logic to compress our data. And as you can see here, we did like some load tests before. So yeah, it was actually spiking with a CPU of 100% and has like a very, very high load on the server. And once we compressed it, yeah, we basically don't see any big peaks. I mean, the load is here just 4, while it was here like 40 or something like that. And yeah, it's of course like side effect as well. I mean, the network bandwidth is way lower as well because all of a sudden we needed to get much less data. And I'm talking more about like magnitudes in there. In our specific example, for example, it was like we had like a 60 gigabytes of database table, which we just like compressed and hexed, and all of a sudden it was like 3 gigabytes. And it's definitely worth to check in your e-commerce setup that you probably also have some table which you can optimize. MySQL, yeah. So now we basically have optimized MySQL in the best way, applied some patterns, changed some configurations. And then we basically migrated along the way already from Memcache to Redis because it's like the logical choice to replace that. But you end up then at the end, very interestingly, that actually also Redis is a problem. Why? Because Redis is single-threaded. And I think a lot of people don't really know it or don't really pay attention to it. But it might be a big problem, because if you have a lot of requests, a lot of processes who are actually changing your data, and you're using Redis a lot internally for getting some data, this might be the bottleneck, because it's basically single-threaded. I put it on the slide. It's not 100% true, but for the cases what actually you are doing, I would assume it's single-threaded, because you don't use this non-single-threaded stuff. And you basically should respect it. So that means like you should think about it, because as more requests you're doing, and as smaller they are, like each single operations, as more requests you can do. I basically put like some numbers in there. And give you also some recommendations. So you should basically never run like some commands like keys or scans on your live data, live Redis instance, when you want to check something, or even not in your application when you want to check, oh, is some key existing? Yeah? This is not a good idea, because it's basically a very expensive operation, and not only takes by himself like 3-4 seconds, but it also blocks like all the other users to accessing this Redis instance. And you should also look in the using efficient Redis commands. So like there are specific things like set and x instead of using access and set. Yeah. You should really just like cache the data in your Redis instance, which you actually need. So basically you should have like smaller objects in there. Yeah, for our example, we are caching very intensively the category tree, but it's not really needed to put like all the properties of a category in the Redis instance. So we are just storing the IDs and the names and maybe something else, because eventually it leads like to faster execution. Also there I gave you like some basic numbers which we basically profiled. And yeah, the second hint of thoughts, like having a smaller data set, is also using the right data types. So Redis has data types. So if something is an integer, use an integer, because it takes like less data. And you should also just accessing your data once. Back in the category example, it's not a good idea running through a loop and basically getting all the time the data from Redis, because there's also like some system-to-system communication. So yes, it definitely makes sense also to store then your category tree once in your PHP object, and then just like retrieve it from there, because you save the bandwidth and you save the interaction, and you keep the Redis free for other threads. You can basically use appropriate TTLs, because they more or less come for free. Yeah, you basically define this cache entry expires in 5 minutes, in 1 hour, and you don't have to take care of it, and it doesn't cost anything. Redis is very efficiently in handling that. And last but not least, you also need to monitor Redis. I mean, so you really need to think, okay, when this happens, like how can I add like more memory in there that's really fit my whole data set, which I want to store also in my Redis instance? How do I get more memory? In AWS, I might increase the box, but I need to think about it before I really using this one, because it can eventually end up in problems. And you should also think about, is really Redis always the best choice? There's like a lot of things where Redis might be not the best choice, where it might be a better choice, like when the data is really big and you don't really need it that often. Why not using a file system? Because, I mean, file systems are not the fastest ones, but if you don't need it so often and it's a very big object, it kind of makes sense, yeah. And even if it might, the file system might be too slow, then maybe use the database. Yes. What came afterwards? So we basically optimized a bit MySQL, we optimized Redis, so we came already pretty far. Like together with our nice PHP monolithic application and our Golang services, workers, which we did something, we could already achieve a lot. But we also realized that's like hard that we need to manage the job. So we basically investigated in a lot of different technologies and checked like some queue systems, but eventually we ended up to using Gman. Not so many companies are using it, but we are very happy about it. What is Gman? Gman is basically a job task server where you can basically delegate some background jobs and some parallel tasks in there. So kind of like during a request, you can basically put some things in the background, like please send my email, because you don't care really when it's getting sent. And you can also trigger like some execution tasks in parallel that you basically, it's basically the synchronous, asynchronous approach. And there is like an extension for the most common languages. Yeah, so it's like super easy to connect Gman with PHP, but also with Golang, but also maybe with any other language later, which we might want to use in our lifetime. There's no single point of failure, because Gman is basically having like a master-master principle, what I explain in a second, and it's very nice horizontal scalable. What actually do I mean there? Before I come to that, but you also need to be aware that all the jobs which are saved internally, they are like saved internally into some kinds of data storage. By default, I think it's MySQL. We also changed it to Redis, but you need to be aware of it. So if you have like 1 million entries, then also your Redis instance gets like slow and the whole Gman things get slow. How does it work in there? To give you like a bit of an outlook, you basically have like your Gman job server in the middle. You have basically like some client application code, which you're actually doing something. Mostly for us, it's the PHP and the Golang part, and you have like some Gman clients, which basically adding some stuff to the job task. Yeah, basically sending out an email as an example, and then in the background there are some workers running. Yeah, coming back to the fact that we're also using like Golang, I mean, it makes a lot of sense because we can basically not only running here some PHP workers, we can also run some Golang workers. And this is basically from the other way around, from the master-master setup. If you're like basically drawing here a boundary of servers, we have here a job server running, we have here a job server running, and you have like some clients who are basically accessing data into your job server, and you are basically having here workers, which basically processing tasks from both systems. Might be from there, might be from here. So it's a very redundant setup, and it's very highly scalable because you can very nicely scale it in a horizontal way. Yeah, so we came already pretty far, and we were like a nice setup, but there was of course still like some nasty, tiny details to solve. And I basically want to look at like in two algorithms and gives you a bit like the idea what we did there, and I just took them a bit randomly in there. Firstly, this dogpile cache stampede effect, and it's always called a bit differently in each internet article, like whatever it might be again, but it's actually always the same problem. It's basically like you have like some cache entries. You have like a cache hit, and everything is fine because you basically deliver the cache entry. But as soon as like this cache expires, you basically come up into the problem that you need to regenerate this one. This might be not an issue because you can regenerate it, but the problem is in the meantime you get like more requests in there. It's also trying to generate your cache. So the problem is not only that you're having like 3 requests waiting instead of 1, but you also have the problem that like all of these 3 who are trying to generate the cache key again reduce a lot of load. Yeah. In our example back again about this category tree, this costs a lot of resources. Yeah, on MySQL side, but also on PHP side. So what is actually the solution? Yeah, there's basically 2 possible solutions. If you guide them, mostly in the internet, they talk about a semaphore log, what basically means like the first request basically regenerates this cache entry. And the second one basically waits that the first one also created this one. Yeah, it's a pretty nice concept, but we actually didn't follow it because we basically were more pragmatic and said like, oh, we deliver like the old value. Because we said like when the category tree was valid for like 1 hour, then we can also still deliver after 61 minutes the old cache value. How did we do it with Redis? We basically applied it very simply and just added the single key entry twice, like the value twice under 2 different keys. One key with the normal key expiration time and the other time with no key expiration time. So basically when we realized, oh, the cache key expired, we basically triggered a Gman task again to generate a new value, but we already delivered the old value. So basically it was very instantly for the user because he didn't see a side effect. This is the one thing. The second thing, and that's also an interesting algorithm, and I just also heard before in the last talk about it, it's about Bloom filters. How does Bloom filters work, and what problems do they trying to solve? Bloom filters basically is a hash function. You basically have like a data set, and you run it through a hash function, or to multiple hash function actually. For simplicity, I just used here 2. And you basically run through a hash function, and you basically end up in a bulb. It's like a on-off thing, so you basically turn them both on. Then you basically run the next data set in there, and you also run through the 2 bulb actions and basically turn it on and turn like 2 things on again. 1 was already on, so it keeps being on, and 4 is on again. So now basically, what you basically do is like with all your data sets, what you're basically having in there. And what you actually can do there afterwards, you can like with with any data set, and we can actually check if the data is already in there. What is basically the use case what we have solved there? We have basically solved the use case about checking if a translation is already existing or if a brand is already existing in our database. Because it's of course like brands and translations and even like some product SKUs, they're very, very big, and you have to store them then in a very big way. And the Bloom filters very efficiently because it stores this, I mean the hash function might be not efficiently, but these ones are very, very tiny and can store it in a very efficient way. So you can make some very, very easy lookups to actually check if the data already exists. There's, of course, potentially also the failure of a false positive. So that means, in this example, C actually runs here, when you check now C, at once like these 2 hash functions would realize, okay, is it already existing? And it would think, yes, this thing exists already in the data set, but it just existed because A turned on 7 and B turned off 1. So you have like a false positive and need to take care of it, but it's not so bad because actually you will, like, depending on your setup, how many hash functions you use and how the hash function behave, you can basically control a bit the false positive rate. I mean, it's somewhere between 1% and 5%, depending really on your setup, but it means basically in 95% of your cases, at least, you're holding away the traffic from your main data source. In our case, it was Redis and MySQL, because we don't need to check the data out of there because we know it already if it's there or not. Yes, and that's basically where we are right now in 2017. So the stack changed a bit, but actually it's not so much differently. And actually, I would still say call it legacy, because we still have like a ZF Framework 1 application. It's still in a very monolithic way. Of course, we have some boundaries in here defined, but I didn't put them on purpose because they're not so clearly defined and they might be not so good visualized. But we still have also like a MySQL database here. What we as well have, we have here, so I called them like services on purpose and not microservices, because we realized basically along the way, image processing or like our webhook service, it doesn't make sense to implement it in PHP, so we implemented that in Golang. And we migrated from Redis to Memcache, as I already mentioned in there. Of course, here, this stack also involved in there. So we are not only talking to 2 systems, but I put in there 5. Actually, it's probably more. And I didn't want to be accurate, but to third-party systems. Extend Desk, some ERP systems might be whatever, SAP. Then we have a lot of Gman workers here, where we run that way, as I explained to you. And we also built some applications next to it, which doesn't really have to do with it. What is a bit the recommendation, or why did I wanted to show you that? Because it's basically the idea is that we just really refactor something along the way when it's really needed, and we really be building something when it makes sense, but we don't really touch this part when it's not really needed. Of course, on top of it, we also build it to be very consistently, as said at the beginning. We also added a lot more API endpoints. So we added also an internal JSON-based API, because it's a bit more better to use than XML. And we have also some mobile API. As I said there, we have a mobile app, so it needs also to communicate this one. So we added this on top of it. But actually what happens here behind, we basically decide that if this mobile API is using some Gman logic or some Gman workers or some Go code, we basically are free to define it. We can even change it when we have some scaling issues. Where has this brought us? I mean, this setup brought us to 5 million sellers, 40 million products, and 240K orders on peak campaign days. And that's actually not so bad for a ZF Framework 1 application. Coming to my basically last slide to give it some general hints what we experienced along the way and what we realized there. As I said, we're just building new stuff and services when they're really required. We never build them when they're not. So basically we don't touch and refactor anything without business impact. Because we say when there's no business impact, then we also don't need to do it. Which eventually is also pretty cool as a developer, because you just work on useful stuff and not so much on something what you might never use. And of course, these refactoring projects also tend to be hard to manage in time and resources, because everything always plans out to be more complicated. And we basically also just optimize where needed. I mean, what I showed you, all the MySQL and Redis hints, we not did them because we wanted to optimize, but we experienced some growing pains. As you saw there, with 40 million products to handle, it's not so easy. And all these Chinese sellers who are going into these emerging markets, I mean, they have quite some computing power and some stressing. And they stressed our platform, and we needed to optimize. But we just optimized really when we needed this. So I would say also that our platform is not probably capable of handling 100, 200 million products. We would need to optimize when we are there. Yes. Of course, also, just as a side fact, we also updated to PHP 7. So ZF Framework 1 can also do PHP 7. So you can definitely also work on legacy systems, use modern technology like PHP 7. General recommendation: don't do caching and data duplication unless it's really needed. It always prone to error, because you cache, you need to expire your cache, you need to check when do I need to expire my cache, then you have some data out there. So ideally, you don't need to use it, and just use a primary data source. Question product decision. What do I mean with that? I mean, our product managers always come up with crazy ideas, but sometimes they're also not so useful, and you should always question them. Are they really needed? I mean, there are tools. I think I saw a talk yesterday from Tim about it, where he said there was a feature used by 1.3% of the users, and that's actually what we also faced. When we really think, is it really needed? We basically try to measure, does it really make sense? check especially also useful algorithm. So I think often, like in this whole talks about microservices and what do we need to do, I think we've sometimes forget about the basics. And at the end of the day, I think computing and IT is mostly about algorithms. And I mean, if you get your algorithms straight and you apply this right algorithms for your stuff, you come already pretty far. I mentioned also Packers and Weft, which basically distribute the load very nicely between different computers. And you can basically apply them everywhere. They are not like limited to some language. They're not limited to some use case. Eventually, you can also apply them outside of e-commerce. You could, of course, also check for natural replacement in your tech stack. As you might have saw, I mean, we replaced Redis with Memcache, but also we replaced NFS with ClusterFS. Of course, there would be also a choice to migrate everything to S3, which is probably a bit more sophisticated and maybe the better choice. But of course, it's a bit more hard to migrate because it's not so the natural replacement, because all of a sudden you deal with objects and no longer with really files. We might do it, but we didn't see the need yet. Also, a big recommendation that you should use feature switches, because if you use feature switches, it makes it more easier to deploy, because you can deploy all the time. You can basically turn off the feature, and you can still add more code in there. And once the code is really ready, the whole feature, you turn it on. So it makes sense for continuous integration, for continuous testing. You can show it to your customers, you can show it to business, but don't have 500. So it's like very hard to manage 500 features because then they start like to depend on each other. I need this feature on and this. This is a nightmare, but we will also probably have to reduce it a bit. And also saying no. My biggest recommendation, because a lot of times basically you sit there together with some product managers, business analysts, and they basically recommend you great ideas, and they're often great, but often they're also not so great. So my initiative is always like to say no first. I say like 3 times no before I might say yes. And it makes a lot of sense because it like filters out a lot of first things which might not be so proven. Because of course with technology we can actually do everything, but probably not everything is really useful. Yes, and was it eventually. Are there any questions? I don't see anything. No? I don't see any.
Hi. How many servers are running on is your application running on?
Depends. I mean, globally, this instance, I mean, we of course have like, we have like different installations of the software. In general, it runs like on 3, we generally hosted on AWS, and we run on 3 web servers, and we use RDS, master slave setup, for it. And then in each specific regions based where we are, like for India, we are hosted in India, for Australia, and so on. But like a basic cluster, so a basic setup of our system is like consists of 5 servers, or like 2 RDS instances and 3 EC2 instances.
Okay, so with 5 servers in total, you make 250,000 orders a day?
That's basically the collected number globally, but on peak days, we did also on one server cluster 100,000 orders, yes.
Okay.
There's a question also. Yeah, I think they want to, because of the recording. Yeah, just.
So yeah, it's quite a high number of order per day with only 3 instances. So what kind of instance type did you use for that?
I mean, this 250K is like, it's like a peak order day. You really have to have a peak day. Today is also peak day because there's like some mobile week in Africa. But in general, depends. I think we have like 8 cores then on the EC2 instances. So it would be then basically 32 cores. Sometimes we also ramp them up, but actually we don't really need to do it. At the end, the order processing is also not really our bottleneck in terms of the whole performance, because we just like import them. Because the customers are not placing the orders in our system. We just like basically getting them via an import. So that's not really the scalable problem. The more scalable problem is really like to process all the API requests and process like all the stock updates and the price updates and all the product changes and downloading images and putting them in the right dimensions and stuff like that. That's much more challenging in terms of like importing orders, because eventually these are more or less, really simply speaking, just an insert to the database.
Okay, so I will just ask another question. What you describe is apparently not very cost efficient. So why didn't you like divided your servers in more front-end servers that you can auto-scale or something like this?
I mean, yes, we are working on that. For sure, it makes sense. On the other side, of course, we also need to think that we are backend application. I mean, we are not like customer facing. So like the peak traffic, I mean, like when there's like a flash campaign, when there's TV advertising, it's not touched by our seller center system, because it's just like when the orders are getting processed. Of course, we also see the peaks there because we have more orders and more sellers need to process something. So this scaling thing doesn't really apply, and we don't really have so much of a differentiation between front-end and back-end. But yes, we are definitely also thinking about it. How can we cluster it a bit better having like an own order operation instance and product instance, a bit like what I explained at the beginning, where we have like the differentiation between defining like the boundaries between product and orders, and we're thinking how we can apply it. And it makes sense because we probably need much more computing power on this product changes, updates. And in the last instance, also like giving price recommendations and things like that to the sellers instead of doing this order processing, which is very straightforward, I would say, because it's just like packing some stuff and putting some labels on there on a very simplified way. Of course, it's a bit more complicated.
Thanks.
Then, thank you.